Hello again. So here's the second part of question 32. This function has stationary points there and there. Use calculus points. Okay, so to find the I'm going to set up a gradient table. So I've got my x and my f dash of x, and I'm going to find some values. I know it when x is -6. The gradient is 0 because I'm told there's a stationary point there, and I know that when x is 0, the gradient is 0 there. To the left hand side of that -6, well, that's going to be -7, and I'll work out what the gradient is doing there. Now, going back to this is my gradient equation, or my derivative equation. That's the one I'm going to be looking at for this. If x is -7, well, this term will always be positive because it's x squared, and this term will always be positive because, again, it's a squared term. It's the x plus 6 is the only thing that can change in value. It can change in sign, positive to negative. So when x is -7, this will have a negative value, so the gradient will be negative. I have to be a little bit cautious in this space here between -6 and 0, because if you look at the equation, you'll see that when x is -4, there will be an asymptote because this function is not defined when x equals -4, because you get 0 on the bottom. So I'll just be a little bit cautious about that, and I'll go to -5 just to consider what happens there. Now when x is -5, we get 6 minus 5, that will be +6, minus 5, that will be +1, so there I'm going to be positive. Then on either side, I've worked it, I can see what's going to happen there. Now on the other side of the 0, again, I'm just going to avoid the -4, so I'll just go to -1 to the left hand side of the 0 and see what's happening. At -1, that's going to be positive, because 6 minus 1. And if I go to the other side of 0, let's go to +1. I guess this one is 7, that's also positive. So from that, I should be able to see what's going on. I've got a negative, so my gradient's like that. Then I've got a 0, and then I've got a positive, and then I've got that bit in between, because somewhere in there I've got a -4 and it's not defined. But I'm not worried about that because I'm only actually interested in these 2 points. And then I have to consider the 0, 0 point, so I've got a positive, which is that way, and then a 0, and then a positive again, so it's doing that. Okay, so from that I can see that at this point I've got a local minimum, and at this point I have a point of inflection on a rising, stationary point of inflection on a rising curve. So what I've got here is then natural point, so -6,108. That is a local minimum, and the point 0, 0 is stationary point of inflection on a rising curve, and that is that.